Welcome to educator.com. This lesson is about graphing linear functions. In this lesson, you will learn to graph linear functions. And some applications are that you'll be able to predict constant change over time. For example, the amount of money that a person may need to save each month in order to stay within their budget. A solution is any ordered pair, any x and y value that makes an equation true. A linear equation is an equation with solutions that lie on a line. In fact, if you look at the word linear, in the first four letters you'll see the word line. So this is when all your solutions, if graphed, would lie in a straight line. A linear function is a function rule with solutions that lie on a line. So once again you have the word line in the word linear, and all your solutions lie on the line. So it's very similar to linear function and linear equation are very similar in their definition. Let's try making a graph from a table. Suppose you save $2 each week. Use the table to make a graph of the relationship between the number of W weeks and total savings in Y dollars. So our input, as we learned from our last lesson about functions, is represented by W, and the values are given to us, 0, 1, and 2. And the total savings is our output, Y. So we're saving $2 each week. So in our initial week, our starting point, 0 weeks, we have $0. After the first week, we've saved $2, and by adding another $2 in the second week, we've saved $4. So now let's make a graph of the relationship between the number of weeks and the total savings in dollars. So a graph is just like the coordinate plane that we learned to make in a previous lesson. You want to label your axes, x and y. And in this case, instead of using x, you can see that they chose to use w. So you want to make sure that you label your axes correctly so that the numbers are represented correctly. You don't want to confuse the y values 0, 2, and 4 with the w values 0, 1, and 2. So I'm going to make just some lines. If you have graph paper available, that's very good to keep your graph more accurate. And we start off at 0, 0. And then next is 1, 2, and then 2 and 4. So here you see the relationship is growing in a steep value. So you could use this graph to predict much later on. If you've gotten the picture drawn, you don't have to count week by week. You could go across your graph and go up to meet the dollar amount to predict the value or to find your later values. Let's try graphing a linear function. Graph the linear function y equals a half x plus 2. So we're going to be looking at y equals a half x plus 2. So first off, you want to start by making a table. So your x values are your input and your y values are your output. These are the values you're going to be substituting. Notice we weren't given any values, so it's up to you to choose values. A lot of times it's easy to choose 0 because that's an easy number to work with, and lower numbers such as 1 and 2. You really only need 2 points to make a line, but sometimes it's good to create at least 3 points to make sure that there are no mistakes in your line. So if I input 0 here first, I get y equals a half 0 plus 2. That's y equals a half of 2 and y equals 1. So my first output value is 1. So I have the coordinates 0, 1. My next value that I'm inputting is 1. So I have y equals a half 1 plus 2. And y equals half of 3. So I could say y equals 1.5. So my next ordered pair is 1 and 1.5. And then next is input of 2. So y equals a half 0 plus 2. Oops, no, this is an input of 2 here. The 2 was already there, so y equals a half of 4 and y equals 2. So my last order pair is 2, 2. So let's come to our graph here. Here's my x-axis and my y-axis. And I see that my ordered pairs only go from 0 to 2, so I don't have to draw very many lines here. So I start off at 0, 1. That's my first point. Next is 1 and 1.5. So 1.5, I'm going to go to the 1 and then halfway between the 1 and the 2. That's 1.5. And then next is 2, 2. So now you can connect and create your line. So we've just graphed the linear function, and you could always label it y equals a half x plus 2. So this line right here represents this function. You eat 5 servings of cereal from a 32-ounce box. If each serving of cereal is 2 ounces, how much cereal is left? Okay, well, this is missing a piece of information here. If each serving of cereal is 2 ounces, how much cereal is left? So we want to say how much cereal is left after. We need a certain amount of days because we need some input values. After 6 days, let's say. Okay, so this can be our input now. So 5 servings, oh, actually 5 servings would be our input. You know what, this is actually fine as it is. I guess we're saying that this problem is assuming that you eat 1 serving per day, and this represents 5 days. Okay, so that will be our input. So 5 servings over 5 days, 1 serving per day. So if each serving of cereal is 2 ounces, how much cereal is left? So we're starting off with 32, and we're going to be subtracting 2 times the day. 2 ounces per day. That's what this portion represents, and this is the total. And then what you would have here is left over. So I'll call it L. Leftover equals the total amount that we started with, 32 ounces, subtracting 2 ounces per day as the day changes. And we know here that we're saying it was for 5 days because 5 servings were eaten. So what's left is 32 ounces minus 2 times 5. So over 5 days, 2 times 5 is 10 ounces. So 32 minus 10. 5 days later, you've eaten 10 ounces, and what's left of the original 32 is 22. So how much cereal is left? 22 ounces after the 5 days. Graph the values in each table, then connect the points with the line. Okay, so with our first table here, we have an input of -2, 0, 3, 5, and 1, 3, 6, and 8. So let's create our table. This indicates a coordinate of an ordered pair or a coordinate pair of -2, 1. Remember that the input is the x value and the output is the y value. This would be 0, 3, and 3, 6, and 5, 8. Let's create our graph here. This is your x-axis, and this is your y-axis. It's helpful to look ahead and see how large your graph needs to be. I know I need my y to go up to at least 8, and then my x value is going to go into the negatives and then at least up to 5. So maybe I could lower my x line here so that I have enough room for the y to go up to 8. It's good to look ahead like that so that you don't have to redo your entire graph after plotting a few points. All right, so we start with creating lines here. If you have graph paper, it's good to use the graph paper so that you can create as an exact 1, 2, 3, 4, 5, 6, 7. I need to go a little bit higher so I can hit that 8. And that's y, 8. All right, so let's start graphing here. -2, 1, 0, 3, 3 and up 6, and then over 5 and up 8. Good. It's also helpful to use a ruler if you have a ruler so that you can create a straighter line. It's pretty close there. A little bit above. Okay. So if you have graph paper and a ruler, that will alleviate your problem of having the dots maybe not form a perfect line. But here, this is close enough here. So we have negative 2, 1, 0, 3, 3, 6, and 5, up 8. Graph the linear function y equals negative 2x. Now when graphing functions, you want to always start with creating an input-output table. And you really only need 2 values. You only need 2 points to create a line, because once you have 2 points, you can connect them, and there's your line. I'm going to pick 0, 1, and 2 because 0 is an easy number to work with. And I'm going to pick 3 values, but I'll show you how the 0 and 1 will suffice. So we have y equals negative 2x. X is going to be our input value. Y is going to be our output value. So I'm going to start off with 0. Y equals negative 2 times 0, and y equals 0. So 0 is very easy to work with there. And then y equals negative 2 times 1. And y equals negative 2. And then y equals negative 2 times 2, and y equals negative 4. So here's our input and our output, and that has created for us 3 ordered pairs. Okay, so I'm going to draw my graph. Here's my x, and here's my y axis. So first, I see that my graph does not have to be very large. Okay, so starting at 0, 0, I have my first point. Next I have 1, 1 and negative 2. So see that with just these 2 points, I can already create a straight line. You really only need 2 points to make a line. So there is the function y equals negative 2x. Now just for a last point, let's check if 2, negative 4 falls on that line, because according to the rule of our linear equation, all the solutions should be on the same line. So if I were to go positive 2 and come down 4, it would be about here. And yes, it does fall on the same line. So you really only need 2 points, but it's nice to check with the last point. Graph the linear function y equals 2/5 x plus 3. So y equals 2/5 x plus 3. Once again, we're going to put an input and output table. So x and y. Now this is an interesting linear function to look at because it has a fraction of 2/5. And when you have a fraction like that, which is sort of small, it might be difficult to find the exact location on a graph with unit squares. So what I would do is choose x values that are multiples of 5, because if I use 5/5, that would cancel to 1, a whole number. 10/5 would be 2, cancel to a whole number. So if you use x in multiples of 5, you don't have to worry about the fraction because this 2/5 will cancel out to a whole number. So of course I'm going to start with 0, that's always the easiest, and then I'm going to choose 5 and 10, multiples of 5. So y equals 2/5, put in 0 here, plus 3. So 2/5 times 0 is 0, and that leaves you with 3. So a nice whole number to work with. Next, we're going to do y equals 2/5 times 5 plus 3. So here the 5/5 cancel to 1, and you're left with 2 plus 3 is 5. So a nice, easy whole number that you can graph. Y equals 2/5 times 10 plus 3. And that's going to be 2 times 10 is 20, divided by 5 is 4, plus 3. Once again, a nice, easy whole number. So if you see a linear function that includes a fraction, use input values that are multiples of that denominator, multiples of the denominator here, because that's going to help you be able to cancel out the fraction and have a whole number. That's much easier to put on a graph. So we have y, my largest y value is going to go up to 7, and my largest x value is going to be up to 10. So I probably need to extend this a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. If possible, it's good to put at least 1 or 2 extra marks from the graph, from your largest number, so that the graph doesn't look like it's, the linear function doesn't look like it's coming off the graph. So here is our graph, and we start off with 0, 3. Our next point is 5, 5. And so remember that once you have 2 points, you've really got all you need to create your line. But I did an extra one here, 10, 7, so let's also graph that one. 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I'm right here up to 1, 2, 3, 4, 5, 6, 7. Over here. So they're pretty much all in a line here, and then it's good to use a ruler to connect them. And there's your linear function, and you can go ahead and label it y equals 2/5 x plus 3. Thank you for watching educator.com.